Then we move to chapter 3, numerical methods. Okay, in chapter 3, you will learn 6 subtopics. Root of nonlinear equation, interpolation, numerical differentiation, numerical integration, and then numerical solution of ODE, and last one, numerical solution of PDE. Okay, today you will learn roots of nonlinear equation. Okay, method to solve roots of nonlinear equation. Okay, let's look at what is nonlinear equation. Okay, for linear equation is equation that has 1 degree. 1 degree or power 1. Kuasa 1. Okay, for example, y equal to 2x plus 1 or 3x plus 5 equal to 0. Okay, this is linear equation. Okay, here we have sine x. If we have sine x or exponent x, then the equation is a nonlinear equation. Here we have x power of 3. Then the equation is nonlinear. So we want to solve this nonlinear equation. We want to find x. Okay, what is x? Okay, for linear equation, it is quite easy to find value of x. But it is harder to find value of x for nonlinear equation. Okay, we have 4 methods to find x, to find solution of x, which is a bisection method, Newton Raphson method, secant method, and fixed point iteration method. For bisection method and Newton Raphson method, it is based on this theorem, intermediate value theorem. Okay, what is intermediate value theorem? Okay, using this theorem, we want to find where is our solution. Okay, we want to find interval that contains solution. Okay, let's say fx, okay, our function is continuous in this interval AB, where fa multiplied with fb less than 0. Okay, meaning that fa and fb have different sign. Then there exists at least a solution C where fc equal to 0. So remember that we want to find solution when fx equal to 0 and we want to find this x. Let's say I put A is a 1 to 2. 1 until 2. Okay. 1, this is 1 and this is 2. And then we find F1. F1, you substitute x equal to 1 in this fx. And then you get, let's say you get 2. And then find F2. Then you get negative 1. You notice here F1 and F2 have different sign. This one is positive and F2 is negative. So based on this theorem, there exists solution in this interval. Okay, there exists the root of x. So here ada solution dalam interval ni. Okay, if let's say we have 2, 3. We have interval 2 until 3. Okay, F2 equal to 2. F3 equal to 4. F2 and F3 have same sign, which is positive. So, in this interval, there is no solution. So, no solution in this interval. Okay, this theorem is very important to determine the interval that contain the solution. Let's look at example 1. Okay, find the possible subinterval that contain the solution of fx in the interval -2, 3 with step size h equal to 1 using intermediate value theorem. use 4 decimal points in your calculation. Let's do in table. X, fx. And then sine of fx. Okay, x start from negative 2 with step size h. Okay, reduce 1. So negative 1, 0, 1, 2, 3. Okay, and then find fx. Here you substitute negative 2 in this equation.
Our function is x cubed divided by 3 minus x squared plus 1. So choose alpha x power of 3 divided by 3 then minus alpha x square plus 1 and then choose cal, C-A-L-C. X we substitute negative 2 equal negative 5 point. Okay, we want 4 decimal places, so negative 5.6667.
You can calculate like this. Okay, negative 2 power of 3 divided by 3 minus negative 2 square plus 1. So the answer negative 5.6667. So the sign of fx is negative. And then to calculate for another x, you just choose cal again. And then just put negative 1. Okay, we want to find the interval that contain solution. So, then choose different sign. Yang ni sama. So we choose negative and positive here. So there exists solution in this interval. Negative 1, 0. And then here, positive, negative. 1, 2. And then 2, 3. Okay, next we move to bisection method. Okay, remember we want to find solution when fx equal to 0. We want to find x. Okay, bisection method use bracketing method, bracket. Okay, we start with two initial guess. We start with say A, B. A and B. And then we find the middle point, C. So C equal to A plus B divided by 2. Then we get C. And then using the theorem, okay, we find the interval that contain the solution. Okay, that's why here we have, okay, let's say, okay, we have the first interval, A and B. And then we find the middle, the midpoint, P. Then you check then you calculate FA, FB, FB. Okay, for here, you calculate FC, FA and FB. And because we want to determine the sign. If they have different sign, so there exists solution in the interval. Then you choose, let's say, A have negative, C positive. positive. So we choose this interval. Okay, the next iteration we choose this interval. Because we know that there is a solution in this interval. Okay, next, then we find, for this interval, we find the middle point. Okay, between A and C. Okay. Okay, then you proceed until the size of the interval will decrease until FC equal to 0. Okay, this is the indicator to stop the iteration. Or if the question gives you
epsilon,
the error of tolerance, then you must calculate the error. And so this method will always converge. Convert. What is convert?
we
What
are
is
approaching
convergence?
the solution.
So this method will always converge, will always approach the solution because we choose the interval that contain the solution. Okay, you must understand how the method works. Okay, let's look at example 2. Try to answer the question in the form of table. In table, we start the iteration at I equal to 0. Okay, find the solution of, okay, this is our fx in this interval 0 to 1 by using bisection method. Okay, use 3 decimal places. Okay, so for this example, I want to show you when to stop the iteration when fc equal to 0. So 0, 1, and then calculate the middle point. We have 0 to 1. Okay, so calculate C. 0 plus 1 divided by 2 equal to 0.5. Okay, next you calculate FA, FB, and also FC. So here is 0.5. Okay, substitute 0, 1 and 0.5 in this equation. Okay, input in your calculator exponent negative x minus x, and then choose cal, C-A-L-C, A equal to 0. So FA equal to 1. And then choose, and then calculate FB, cal, and then put 1. Then you will get negative 0.632 equal to 0.5. 0.107. Okay, this column, this column is for interval that we choose. Interval that contains solution. This one is FA, this is FC, and FB. Choose FA, FC, or FCBC. AC or BC. Okay, do not confuse. AC and ACBC. So we choose different sign. BC. Okay, positive and negative. BC or CB. Okay, then we choose this, this interval for next iteration. Okay, next iteration 1. So our A now will be here. BC. 0.5, 1. And then find the middle point. We'll get 0.750. And then repeat the step. Your exponent that you have input earlier, and then just click and then choose cal. 0.5, okay, 0.107, and then 1, negative 0.632, FC 0.75, negative 0.278, and then choose the interval that contains solution, AC or BC. So we choose A and C because they have different sign. A, C. A and C. So for second iteration, choose 0.5 and 0.75. And then find the middle point. 0.5 plus 0.75 divided by 2, you will get 0.625. And then substitute the values of F. Okay, here we choose FA and FC again. Okay, and then proceed with the iteration. Okay, until your FC equal to 0. Equal to 0, then stop the iteration. So the value of C will be the root. Will be the answer or the solution. So the root of fx is approximately 0.567. Okay, for example 3, okay, I want to show you when to stop the iteration when if given error of tolerance. In this question, error of tolerance is given. Okay, then how to stop the iteration by using error. So in your table, you should have I, ni makin panjang, I, A, B, C, F, A, F, B, F, C, and also error. A minus C
Epsilon.
should be less than or B, C. Okay, we start the iteration, remember, at I equal to 0. Is the first iteration, the first interval will be 1.5 until 2. 1.5 to the step there sama je, and then find the middle point which is 1.75. Okay, and then substitute A, B, C in fx. This is our fx. Fx equal to x power of 4 minus x minus 10. Okay, when you calculate, you will get negative 6.438 4, and then negative 2.371. Okay, how to determine the error? Okay, the error. Okay, first we choose the interval that contains the solution. AC or BC. So we choose AC. At BC. So find the error. Kira 2 minus 1.58. 0.25. So 2 minus 1.75 equal to 0.25.
Equal.
Okay, you will stop the iteration if this error 0.015. Okay, proceed. 1.75 and 2. And then find the middle point. 1.875. And then you calculate FA, FB, and also FC. So we know that FA and FC have different signs. So we choose AC. Okay, good, correct. So A and also C. And then find the error. So we take modulus. 1.75 minus 1.875 will be negative 1 over 8 or negative 0.125. Okay, and then because we modulus, and it become positive 0.125. Then we proceed until iteration 4. When you get the error is 0.015. Because the error for this iteration equal to error of tolerance given in the question. So we choose our solution. Okay, the root of solution equal to is approximately 1.86. Okay, I'm to proceed to Newton Raphson method. The aim is similar. We want to find x, the root of x when fx equal to 0. Okay, Newton Raphson method require one initial guess. If we have one initial guess, then you can find the root. But for bisection method, you must have two initial point or two initial guess because we want to determine the midpoint. Okay. For Newton Raphson method, if we have x, you must determine the derivative of f or f prime. And also one initial value. So from one initial guess, x naught, okay, to determine the next point, you will use this formula. So x1 is given by x naught minus
graph for
fx naught divided by
equal to fx.
f prime x naught. Then, if we have this initial guess, you find the tangent line. This is the tangent line given by f prime. And then we use this line, this tangent line, to find the second point, which is f, in this example, P1. Dah dapat P1, then we determine the tangent line again, or the slope, f prime. Then you proceed the iteration until, okay, you stop the iteration when fx equal to 0 or the error of calculation less or equal to the error of tolerance. So for this method, it is not guarantee that the method is converged. Okay, because it is depend on the initial guess. But if the method is converged, it is much faster than bisection method. Okay, look at example 4. Use the Raphson method to estimate the root of fx. Accurate to, okay, for this example, you must calculate the error. Okay, given the initial point is 1, use 4 decimal places. Draw the table. You must have I, xi, fxi, and also f prime xi, and then the error. Okay, you start with 0. So x0 is the initial point, which is 1. And then calculate. This is our fx. Fx equal to x squared plus 2x minus 5. Okay, and then find f prime x. F prime x equal to 2x plus 2. Okay, substitute 1 in here. And we'll get negative 2. F prime, we'll get 4. So, tak ada error for first iteration. We don't have error. Okay, then next iteration. Okay, we want to find x here. Okay, that's why we use this formula. x1 equal to x naught minus fx naught divided by f prime x naught. X naught is 1. 1 minus 2 divided by 4. And we get 1.5. Okay, and then find f. Then substitute 1.5 in fx and also f prime x. Then you will get 0.25. 5. And then calculate the error. Error here is between this x, 1 and also 1.5. The error is 0.5. Okay, 1 is 1.5 minus 1. Okay, next, proceed. Because we want the error to be less than. Okay, remember. Here, the error is less than 0.005. But here, for second iteration, the error is 0.5. Okay, we proceed to 3, okay, until 3. Okay, 3 we get less than 0.001. Then we stop the iteration here. So our point will be here. So the solution, the root of fx is approximately 1.4495. This is the solution. Okay, so remember for Newton Raphson method, okay, you will use just one initial guess. Okay, then you find fx and also f prime x. Okay, you substitute the initial point into fx and f prime x. And then to find the next point, you will use this formula. Okay, for example 2, okay, error of tolerance is not given. Then you stop the iteration when fx equal to 0.